Hello, welcome to my channel. So in this video we are going to discuss about round robin scheduling algorithm. Okay. In the previous video, the first come first serve scheduling algorithm. So the main criteria here is arrival time, right, in the FCFS algorithm. But in the case of the round robin scheduling algorithm, okay, so we are going to take the time quantum plus arrival time. Okay. So the CPU is going to execute all the process with a particular time limit. Okay, so it is going to execute all the process, but it is going to execute each and every process for a particular amount of time. Okay, and it is going to serve all the process like that. Okay, suppose the time quantum here is 2. Okay, then it is going to execute all the process for 2 units amount of time. Okay, so there is a time sharing between all the process, and here the main advantage here means it can execute all the process very faster. Okay, suppose if there is no time quantum here, then this scheduling algorithm will act as a first come first serve scheduling algorithm. Okay, if there is no time quantum, then means the only criteria here is arrival time, right? Then it will act as a FIFO or first come first serve scheduling algorithm. Okay, and now we are going to execute this scheduling algorithm. And normally in the scheduling algorithms, we are going to take only one queue, right? That is a running state queue. It is called as a Gantt chart. And here we are going to take another queue that is called as a ready queue. Okay, we are going to maintain the ready queue also. And round robin scheduling algorithm is preemptive. Preemptive means the CPU is going to execute the process by context switching, right? There will be a context switching between among this process with a time limit, and here the time quantum is 4. So time quantum is 4 here. Okay, so we are going to execute each and every process with a certain time limit. See, now first we are going to see what is the ready queue. Okay, so ready queue and running state. Okay, running means Gantt chart. Okay, so running ready queue and running queue. We are going to take these two. Okay, so in the ready queue, so the arrival time is 0. So the process P1 has arrived at the ready queue P1. Okay, so then, so in the running queue, we are going to maintain the running queue here also here. Okay, so ready queue. So at the arrival time 0, what is the process that has entered the ready queue? That is P1 only. So P1. Okay, so what is the time quantum here given? 4, right? So it is being executed for the 4 units of time. And then, so at the 4 arrival time, what are the processes that have entered the ready queue? Okay, P2, P3, P4 and P5. So these are the processes that have entered the ready queue. P4 and P5. Okay, these are the processes. So now P1 has completed the execution here. So it is swapped out. It is swapped out by the CPU. Okay, so P1 is swapped out and P2 is taken here. So here the swap out and swapping. Context switching is done here. Okay, so P2 will execute for 4 units of time, that is 8. So here the P1 is completed, right? Is finished. Next P3. Okay, so sorry, we have to check the arrival time. Each and every time we have to check the arrival time here. That is 8. So for the arrival time 8, so all the process has entered the ready queue. So the only P6 is left here, right? So we are going to write this. So P6. Okay. So now we are going to swap out the P2 and swapping the P3, right? So what is the burst time of P3? Sorry, what is the burst time of P3 here? 3, right? But the time quantum given here is 4. The time quantum given here is 4. Okay, so no problem, we can execute the given process faster, right? 8 plus 3, 11. So next one, so P3 is finished. It has completed the execution. Okay, so it is finished. So next P4. So we're going to load the P4 process. So P3 is swapped out here. Okay. And P4 will execute for 1 unit of time. So 12. Okay. And since it has finished the execution, it is also not again taken for execution. Right? It has finished the execution. The next one is P5. So we are going to take the P5 and it will be executed for 4 units of time. So here the P1 has executed, right? So for 4 units of time, the remaining time is 1. And similarly for the P2, it is executed for 4 units of time. The remaining time is 2. And for the P3 also, 0 and 0. Now P5 is executed for the 4 units of time. The burst time is decremented by 4, right? And it will become 16. Okay, P5 is 16. So next P5 is swapped out here. So it is swapped out of the running state. And P1 is taken here. Okay, so P1 is taken. And it will execute for 1 unit of time. 17. So next one. So P1 is, it has completed the execution. And the next one. What is the next one here? P6. So P6 will execute now. Completely 0. Okay, P6 is taken here for 4 units of time. So 17 plus 4, 21. Okay, so P6 also finished the execution. So next one is P2. So P2 will execute for 2 units of time. Okay, it will execute for 2 units of time, 23. And the next one. So P2 also has finished the execution. Right. So P2 has finished the execution. Now we are going to put into work for this one. And the remaining one is P3. Sorry, I have taken the P3 also. So sorry. The P3 is already executed, right? Okay. So the remaining one is P5. So it will be executed here. P5. Okay, for 1 unit of time. That is 24. Okay. See, all the process has completed the execution. Okay. So we have to swap in and swap out the given process here. And we have to execute only 4 units of time, each and every process. If suppose there is less amount of burst time, then the CPU can easily execute, right? If the burst time is less than 4, then it will execute for that amount of burst time. And the next one is the completion time. We have to calculate the completion time, turnaround time and waiting time, response time. So here the completion time is for the P1. So P1 completion time is 17, 23, 11, 12, okay, and 24. For P6 it is 21. Okay. Next the turnaround time. Turnaround time means completion time minus arrival time. So 17, 22, 9, okay, 9, 20, 15. And the waiting time. So waiting time means turnaround time minus burst time. Okay, 17 minus 5, that is 12. Next 16, 9 minus 3, 6, 9 minus 1, 8, and then 20 minus 5, 15, 15 minus 4, that is 11. Okay, and the last one is response time. So for the response time, we have to take the CPU first time minus arrival time. Okay, so CPU first time is, what is CPU first time for the P1? 0. So 0 minus 0, 0. Okay, and then for the P2, so for the P2 first time is 4. 4 minus arrival time, 3. So P3, 8. 8 minus arrival time, 2. That is 6. And for P4, so here the first time is 11. So 11 minus 3. Okay, it is 8. And the next one is the P5. For the P5, 12 is the first time. So 12 minus 4, 8. and P5. Here P5 is, sorry, P6. P6, 17 minus 5, that is 12. And you have to calculate the turnaround time, average and waiting time here. Okay, so total by 6 and the waiting time also total by 6 here. Okay, so 18 plus 36, sorry, 35 plus 22, that is 7, 57, and then 77 plus 15, 77 plus 15, 92 by 6, and waiting time is 16, it is 76 by 6. So that is the average waiting time and turnaround time. Thanks for watching my video. Please do like, share and subscribe. Thank you.